Okay, so welcome everyone. My name is Ahmad Sabri. I am the president of the Association of Civil Engineering Students. I think you can see our logo behind me. Yeah, so I'm a fourth year civil engineering student from Kenyatta University. Thanks a lot for joining us. Together we have Mr. Tashfeen, who is going to make a presentation on digital twins. So feel welcomed, feel at home. So just some few housekeeping rules. Please make sure that your camera is turned off. But if you're comfortable, Mr. Tafshin, what do you think about the cameras? Yeah, if you're comfortable enough, you can let them on. But most importantly, make sure your mics are turned off. So we will have a Q&A session. So make sure you have a notebook, and you can be jotting down some notes. And in case you have any question, you can write it down. So during our Q&A session, I'll be giving people a chance to speak one by one. But if you can't speak, feel free to add your question on the chat zone anytime you want, and I will be reading them to Mr. Tafshin. Thank you, and welcome. So you can go on, sir. Thank you.
Just confirm that my voice is clear and you can see the PowerPoint.
Yeah, both are okay.
So thank you very much, President, for warm welcome. Thanks everyone for joining. So today we are going to talk a little bit about digital twins and their applications in built environment, construction, and maybe some other things also, because construction and built environment is a very big area and a lot of things can fall under that domain. So it is not strictly on that area, but overall getting to understand some things about digital twins and how we can go about them. Just an introductory level talk on digital twins. Yes. So digital twins are set for rapid adoption, rapid growth in this year and beyond. More and more companies are trying to explore this area. Of course, it is not applicable for all companies because there are many things associated with that which we need to keep in mind before we adopt digital twins and similar technologies. But still, it is very interesting and upcoming area for many countries, and we will see examples during these presentations. But just to start off our presentation, that there are a lot of growth potential for digital twins and applications for digital twins. Many predictions are happening there in that front. I don't have a set year in my mind to share with you that this will happen in 2030 and this will happen in 2040. But people are talking about it that in next 10 to 20 years, a lot of things will change, especially since the latest advancements in generative artificial intelligence and so on. Many people are seeing that, using those things. So they are seeing that in next 15, 20 years, a lot of growth application we will see in our daily life across different continents. So what are digital twin? Is many different ways to explain it. I'm using IBM definition. You can see it on your screen also and read that as I try to explain that. Is a virtual representation of an object or system. The important point here is the emphasis on real-time data. Yeah, real time. So digital twin, and the difference between digital twin and other application like a simulation is that is a real time data transfer. Yeah, and also transfer of data from both ways, going in the digital twin, data going in the digital twin, and data coming out of digital twin. Those are few little differences which makes digital twin different from a simulation and other type of things. Yeah. How does a digital twin work? There are sensors, a lot of sensors are there. They collect different type of data for various areas in terms of performance, energy output, temperature, weather conditions. These are some things which you can relate with, as I assume most of you are from construction, built environment industry. So it can help in that if we can use a lot of sensors to collect data there. The difference between digital twin and simulations is very important to understand. Many times some people use the term of digital twin, but if you look deeply into that, it is not necessarily a digital twin, it is a simulation. And not trying to say that simulation is not of importance. Simulations are of a lot of utility, a lot of importance, and many times what we maybe need is just a simulation. Do we really need a digital twin? In which situations we really need and afford in terms of cost? uh, Making a digital twin, that is something which we will explore in our presentation. Yeah, so two-way flow of information, they are emphasizing on that again. Yes. Types of digital twin, many different types are there. Nothing to get confused, as you will read um, in the literature. You'll see a lot of different type of definitions. You will read a lot of different types of digital twin. A big, the digital twin, the biggest digital twin can be as big as digital twin of Earth, which European Union has commissioned. They are making a digital twin of Earth, or digital twin of ocean, and it can be as small as a small component. And we will see these things as we go forward in our presentation. So some things to keep in mind here: component twin, parts twin, you know, asset twin, system twin, process twin. So it can be something tangible as a unit, or it can be also something intangible also, for which digital twin can be made, for example a process or something like that. Yeah. History of digital twin, you should read a little bit about the history also. That helps in understanding where we are coming from, how far we have developed, how old is this thing, why it is taking a lot of buzz right now in 2020s, when NASA pioneered the use of digital twin during its space exploration mission of the 1960s. So it goes back around 60 years. And so, yeah. But then again, you can reflect on that from that time only, companies who have a lot of money, only they are able to really use well the utility which can come from digital twin, because it is complicated, and we will explore that going forward. Advantages and benefits which we can reap in construction, in built environment, or in any industry, whichever industry you are interested in: better research and development, improve efficiencies, product end of life cycles. What are some of the benefits? Performance, predictive capacity, predictive capabilities, remote monitoring. You know, you have digital twin of a physical asset. You are at your home, you can monitor the plant on your computer screens, what is happening, acceleration, production time, and so on. What are some of the challenges? You should explore those also. Data privacy, security is a big challenge, because if you have a digital twin of a physical asset, um, it can be hacked, and someone can have access to all the real data which they might not be able to have access if they were to go physically in your plant or in your environment, and so on. Lack of standardization, high implementation cost. This is something which um, we really have to be mindful whenever we are talking about digital twin, because of its complications, or the amount of resources which are required. We need to really think about these things before we start thinking about digital twin. That is why I said many times simulation can do a lot of things which are useful, and they can do the thing, and we don't necessarily have to go to the route of digital twin, technical complexity, and so on. Digital twin market and industries, a lot of different areas can be explored. Physically large projects like building, bridges, other complex structures bound by strict rules of engineering, mechanically complex projects, jet turbines, automobiles. And as we are talking about, you can run some searches. For example, Tesla, just run a search, Tesla digital twin, you will see something here. Uh, BMW digital twin, you will see something there. Um, uh, Rolls Royce, they make jet turbines on digital twin. Rolls Royce, and you will see jet turbines there. Power equipment, manufacturing projects. So the sky is the limit. It is why I am talking about these things and not just construct, is that it is good to understand the underlying fundamentals which can help you explore digital twin, because if you have the related skill, they are transferable to various industries, and you don't necessarily have to stick with what you are studying, for example civil engineering and so on. So here they have, even in railway designs, building construction, manufacturing, power utilities, and I will explore examples going forward with you. Application, power generation, a lot of countries are using digital twin of their power grids, structure and systems, manufacturing, healthcare, it is being used a lot. You can run a search right now as I'm speaking, digital twin of human heart, human heart, digital twin. So this is something which doctors are already are making digital twin of a human heart. And then what happens is that before a surgery, they will do all the things, all the surgery procedures on the digital twin of the human heart, and then see how the heart will react, and then perform. Once they are okay with whatever is happening in the digital twin of the human heart, after that they will conduct the real surgery. So now, and this thing is already happening. If you will run the search read, you will see that this is not something for the future. This is right now happening in certain countries. So that is now going to, you can now see that what can be the applications in across domains, across different fields. Urban planning, of course, we're going to talk a little bit about that also. The future of digital twin is basically bringing in new industrial revolution, virtual factories, manufacturers use digital twins in the quest for a new industrial revolution, more efficient manufacturing process. And when you are talking about manufacturing, you can think about all different type of industries, manufacturing required for construction, for built environment, and so on. They are talking about factories of the future. Digital twins are virtual representations of machines, products, processes, fed with real-time data. They can predict, optimize production processes, equipment performance, from reliability to quality to energy. And you can keep on thinking about various applications in that domain. What can be some of the risks? Of course, as I mentioned a while ago, security of data and so on, they can produce some type of risks. What can a digital twin prevent? I have here 3 different examples because most of you are linked with built environment construction. So you can read the first 2 also. They are interesting. But the third one, highlighted in red, noise pollution caused by a high-speed road in residential area of Singapore. They are already working on this thing. The company set up a digital twin of the entire city, state. It helps urban planners predict the effects of building activities before they happen. Yeah, so that is very interesting application there. These are the 5 different stages basically on which digital twin happens as it matures. In the middle column, you can see just capturing the reality using different drones and so on, sketches, which I'm sure you guys are very much familiar with. That is how it starts. Then the first stage using 3D modeling. Second stage, connect model to persistent data, because data is important in terms of taking the measurements of the buildings and whatever you are constructing. Number three, making it into real-time data, and that is where digital twin really starts. Before that, it is just a simulation or a virtual copy of any asset. So real-time starts from pointer number three, and the next stage will be two-way data integration, that you are putting in information in the digital twin and it is giving you back some information on what will happen in the future and so on. So for example, there is a component in
Sorry, please make sure you mute your mics. Mr. Tashfeen, please unmute. And please make sure you mute your mics, guys. Mr. Tashfeen, you are muted. Kindly unmute. Sorry for that. Yeah.
You guys can hear me now?
Yes.
Since when I am muted? I did not realize.
I'm the one who muted you by accident when I was trying to mute one of our students.
No problem. So two-way data integration, which is really going to make digital twin a powerful tool. And then obviously the real application of digital twin, when it can give us autonomous operation where there is no requirement or less requirement of human intervention and so on. And here I can show you quickly an example. If you can see here, on the left hand side, physical asset, on the right hand side, digital twin. Here is a building, they are creating digital twin of this. They are explaining this first stage, second stage, third, fourth, fifth, as I was explaining. And then look at this, data access. So this will be useful for the residents who are living there, supply chain people, engineers like you who will be, or designers like you, or planners like you who are linked with built environment, and even the government if they want to ensure how the construction should go in a certain area and so on. So it's a very interesting example for that purpose. Yeah. So vacation home, these are now, I'm just going to talk about some examples now in various areas of which will link with digital, with built environment and construction. So Matterport signs multi-year partnership with Vacasa to provide digital twins for international portfolio of vacation homes. You can go on their website. It's very interesting example. People who want to have access of the homes, they can go in that environment and virtually interact. It is not 100% a digital twin, but it has potential to be created as a digital twin. But still you will see that they are pitching it as a digital twin when it is not 100% a digital twin as per our explanation. So the reason for showing you this is that you need to be mindful about this little difference. Port of Rotterdam utilize a digital twin to track over 80 ships a day and 460 million tons of cargo per year. Just reflect on that. 80 ships a day and 460 million tons of cargo per year. It's a very good, interesting example of using digital twin. Among the more unique and innovative aspects of the transformation is a sensor-packed experimental physical container. That container is called Container 42. This is how it looks, Container 42. And in that, this sophisticated research tool is traveling to partner facilities throughout the world to collect geophysical readings. It sends back data that is consolidated into the ever expanding pool of information. With a digital twin of the port, it is possible to calculate exactly how much cargo needs to be unloaded there. This allows the vessel to sail sooner and with more cargo to its final destination. So, very interesting example uh, of usage of digital twin in port industry. What it does, it saves up to 1 hour in berthing time, which can amount to about 80,000 USD in savings for ship operations and enable more ships to pass through the port each day. So Port of Rotterdam is already doing this thing. You can read more on detail about this if you are interested in this type of thing. City planning, digital twin emerge as the latest tool for growing cities smarter. There are many applications of that where there are some European countries which are in their old downtown area before they build something new, or if they want to make some improvements in the building, they are creating digital twins of those things because of the value, heritage value of those buildings. They don't want to just go and start making some changes in terms of construction or whatever they want to do. So first they do it in the digital twin and then they move forward uh, with that. Yes. Airport operations, airport use digital twin for efficient operations. Train operations, I gave you one example a while ago, Port of Rotterdam, but this one is a little bit different in terms of construction of the railway tracks. And this is very important because in 2022 alone, 1,164 derailments wreaked havoc in the US, inflicting over 220 million in damages. Yeah, we are talking about United States of America. Yeah, 220 million in damages. And let me go back here. How this one works is that along the railway track, they put sensors and they get real-time information on the state of the track, if it is getting weak in certain areas. And of course, human inspection is also there, but because railway tracks are very long and you will need a lot of people to monitor that humanly, it is very taxing. So they are using sensors there and then creating digital twin, and then from there, it can be of a lot of value. Energy systems, electricity, UK developing digital twin to better understand future energy systems. There is a collaboration here. If you can see the highlighted section, UK transmission and distribution grid operator SP Energy and University of Strat are doing some collaboration on digital twins. Maybe read a little bit more on detail, and this can make a good impact on built environments going forward. Digital solutions to optimize our energy grid in order to maintain reliable and resilient supply. Uh, so basically, if we can use these type of technologies, our reliability will increase, and at the end, cost for the company will also minimize in the long run, and satisfaction of consumer will also increase. I found this example very interesting. Chevron, they have created a digital twin, and this is what it is. Chevron, as you know, maybe I hope you know about the company. Even if you don't know, run a search on Chevron, very big company. Above in the picture, you can see one of the location where they are using digital twin. So this is way deep in the ocean. As you can see, they have built this environment for their work there, and then they have created digital twin. So you can imagine the application of this. For example, uh, engineers working in that location, even if they are on different countries, they can come together in the digital twin platform and work in terms of improving the infrastructure and so on. So they don't have to go physically there, and they can, from a distance, they can make changes in the digital twin and then see how the changes are going to impact if they are done in the real physical asset. Very interesting. The technology helped colleagues separated by the Pacific Ocean to collaborate and troubleshoot a solution to an issue in real time, allowing operations to restart faster. Yes. So again, this is very exciting example, but then only a company which is very rich in terms of finances, only they can do this type of thing. For other company, it will not be. It's not. It's very expensive. Yeah. Now let's talk about some of the cities, countries which are using digital twin in different areas of built environment. Melbourne is one example. Australia, Melbourne's water digital twin empowers accurate prediction of recycled water quality. So imagine how it can improve the or help construction industry. And as I'm talking about, I hope that you are running some Google searches also, and whatever is interesting for you, you make a note of that, and in the future you should read about those in more detail. Dublin use digital twin to decide on best strategy for retrofitting. So here in the background of the picture you can see a nice view there. So in that city they did not want to just start building things and mess up the nice view. So before they built something in real, they created digital twins, and then they did a lot of studies there also, like what will happen if the height of the new building is this, what will happen if we built it on the right side of the main buildings, what will happen if we built it on the left sides, how the airflow will change by putting the new building in different areas, how many people will be using those new buildings, what will be the impact on the carbon footprint, uh, how the water will drain, all of that thing in the digital twin. They did the study. It's very interesting if you can find time to read in detail about this. The firm modeled 3 residential tower blocks in the city center using digital twin technology and assessed the full carbon impact and efficiency of 4 different renovation strategies. So this is very interesting. Helsinki, they are in Finland. They are using digital twin for various activities, weaving AI and digital twin technology into its infrastructure operations to bring energy saving and water security to the city. This, I think, is a very important area for the world going forward. The sustainable development goals, 17 sustainable development goals given by United Nations, reducing carbon footprint, reducing poverty, and so on. So you can read in detail about them. If you can link your work or job with those goals, I think future growth is definitely possible. Shanghai harnessing um, digital twin technology to improve city management. In China, of course, they are doing very interesting work in this, and one of the reason is the availability of data for them is relatively more easy than other countries where it's more type of democratic nature of governance. Uh, so they are definitely using that in their own advantage, and which is very good. Victoria, this is government website. Victoria, as you might know, it's in Australia, so they have whole plan for digital twin Victoria. If you have time, you can read in detail, and you will learn quite a few things in your area of construction and built environment. Singapore Land Authority develops digital twin for of all public roads, and they saved SGD 26 million and 1 year of data capturing. When I was in your beautiful country, Kenya, a couple of months ago, where I met Ahmad Sabri, your president of this association. In that, I heard one presentation. I am just recalling it now as I'm talking about this. One of Kenyan presenter, they were talking about the application of digital twin, where they were saying that sometimes there is a lot of water on the road. So the road is constructed and water stays there for a long period of time, and then the quality of road will go down because of the exposure of standing water, because of less drainage system or something like that. And then they were saying that digital twin can be very useful in that area, because we can create digital twin of the road, and then in the digital twin expose the road to the water, and then from there analyze that what will be the impact on the road in next 5 year, 10 year, 3 year, whatever is the timeline. So I enjoyed that presentation. It just came in my mind. So definitely application is there. uh, Belgium, a Belgium consortium of researchers and technology companies working to use data-driven digital twins to enhance the way how houses are renovated to meet the country's climate goal. Yeah, renovation, heritage value, uh, definitely a lot of application. In this one, there is a collaboration between a university and government of UK to bring carbon emissions lower. The researchers will work together with industry leaders and the farming community to deliver intelligent computer code that can produce advice how to reduce these emissions. Yeah, this one is a very interesting example, and the reason is that you can already view the results because the project has been completed. So you can go on this website. This was collaboration between University of Cambridge and so on. Center for Digital Built Britain completed its 5 year mission and closed its doors at the end of September 2022. So 2 years ago, they have completed their this national digital twin program. So you can go on their website, see the details, see the reports they have done, what they learn from there, and then you can incorporate in your own country, and then maybe build expertise in certain areas going forward to build your career in this exciting domain. So this is very interesting. And the reason is it's already done, and you will be able to read some reports and so on. Of course, not everything I think is public, but just see what information is there, who are the people who worked in this project. Maybe take their names, run some Google searches on them, read some other papers from them, the usual research strategies, employ them, and learn a little bit about that. European Commission, as I mentioned in the introductory area of my presentation, that a digital twin can be as big as Earth, whole Earth. This is very interesting. You can read a little bit about that. Destination Earth initiative. Of course, they have put in 150 million euros to start up this thing. So you can go on European Commission website and then see what this project is all about. Destination Earth initiative. Yeah, market growth is very big. There is a lot of opportunity. In 2028, it is expected to grow to 110 billion US dollars. Yeah, so there is a share for Kenya, there is a share for Jamaica, there is a share for Pakistan, all the countries where you guys are from. Yeah, so I want to share this example with you. Um, DHL International Company. Basically, they deal with logistics, but I think their case study is worth studying for people in all areas, including built environments and construction. Let's quickly scan through. their thing, what applications they have. So this is the reason I have selected this case to share with you, because although it is logistics, you will appreciate that a lot of application of construction and built environment is there. So in this logistics example, the ultimate digital twin would be a real-time replica of an entire supply chain network. So in this you can see, and we spoke about how airports are using digital twin, how it is being used in train, how it is being used in port or vessel. So all that will combine here in terms of application. A very interesting case study to look in detail, but I will just quickly go through the main areas relevance to the future of logistic. You can do the stress testing same way you can do the stress testing in terms of construction industry, built environment industry. Just like I gave you an example a while ago, that before they were constructing the buildings, they created scenarios in digital twin, and then they tested it that what would be the emission rate of carbon, or how we should allocate the parking resources, and what will be the impact of so many people, human beings, if they come in the downtown area, how the total environment or ambience will change, even the noise pollution they were testing in that. So stress testing applicable there. Optimizing logistic processes, basically whole of digital twin, the idea is coming from optimizing. You have some resources, you want to get some results by using those resources. Don't want any resource to get wasted, so you want optimal performance. So in that you are optimizing. The same goes for the example I gave you from Kenya in the presentation, where one of the professors was talking about the water on the road. So what he's basically trying to do is optimizing and also predicting that what will happen in next 2 year, what will happen next 3 year, uh, using the data collected by sensors. So of course a lot of investment is required. That is why maybe we will not see a proper full-flung application of digital twins in developing countries like Jamaica or Kenya, but still, we should that should not stop us from learning about these technologies. Challenges. What are some of the challenges? Identifying 4 different challenges here. Uh, Make a note of these. Let's go quickly from, and then you can read the detail maybe later. Real-time high-quality data is the basis for any digital twin solution, but demanding or prohibiting field conditions can limit data access and degrade the accuracy of a digital twin. So basically, if you do not have access to accurate, proper, continuous data flowing in your access, digital twin is not for you. Maybe you should think about something else. Yeah, but data is extremely, extremely important. So if data is important, then even if you are not going in the domain of digital twins, still you should spend some time learning about how to clean data, how to sort data, how to do data analysis, all the things linked with numbers. You should spend some time in that. If you have that skill, that will be transferable to various industries, including this one which we are talking about, because this is a challenge not just here, but across different domains. The future is about the future belongs to people who can read and interpret data uh, in a good way. Yeah. Second challenge, digital twin requires considerable investment in sensor technology, platforms, model development, and high touch maintenance. Yeah. So if you don't have a lot of investment there where you will be able to collect real time data, if that is a problem for now, for your company, for whatever you are trying to do, then maybe digital twin is not for you. Challenge number 3, Some qualities of a complex asset, like its chemical, electrical, and thermal state, can be extremely costly and challenging to accurately replicate, often forcing users to make generalized, less accurate assumptions and simplifications in digital twin models. If you are doing that, you are trying to simplify and so on, then maybe it will be a simulation, it will not be 100% digital twin, so you have to be mindful of that. And challenge number 4, with direct connection to physical object, digital twins potentially pose a security risk, giving cyber criminals a possible new point of entry to disrupt an organization's operation. So just like I mentioned, you should learn the skill set of data analysis. Maybe another field to reflect on is cyber security. If you can go in that domain, you will be useful in the industry related with artificial intelligence, digital twins, and so many other areas, not just be limited in um, built environment, civil engineering, construction. And that should be the goal. You should learn the skill set which is transferable in other disciplines. Yeah, multidiscipline approach you should go for. As I'm coming to the end of my presentation, I wanted to share this example with you. I found it very interesting. Digital twins for hire. So artists, actors, public facing personas are getting ahead of AI's ability to replicate their talents. Please quickly read the highlighted section. Musical artist Grimes announced in April that she would allow anyone, fans, other artists, production companies, to create songs with her voice for a 50-50 split in royalties. Now, this is very interesting. Basically, she's allowing any other person to use her voice and create digital twin of her, and whatever revenues come from that, it's 50-50 split. Music and art fanatics have recently uncovered the ability to recreate and reuse voices, music, and content using AI, along with the ability to change and manipulate it in different ways. 1 week after the music star gave public permission to use her voice, she launched this website and open source software program that can be used to replicate her voice. Yeah. So digital twin of a talent, digital twin of a voice, and earlier we spoke about digital twin of ocean and digital twin of earth. And then I showed you example of digital twin which Port of Rotterdam is using, a moving digital twin. Because the whole container is there and sensors are there and it is just moving, and 80,000 USD in a short period of time continuously they are able to save from there. Yeah. How do we move forward with digital twin? So many things are there, a lot of things are there, but how do we move forward? Yeah. Here is an interesting layout. AI in built environment, you can use robotics, predictive behaviors, ambient intelligence, digital twins, and so on. Applications in energy, we spoke about that. Mobility, healthy working and living environments, basically improve the security. If we can perform the task in digital twin, we can improve the security of human beings. Heritage, we spoke about that. Smart cities, buildings, we spoke about that. Industry 4 in construction, all other things outside of digital twin, robotics, and so on. So all of that is part of that. But having said that, what is the, how to go forward? How do we move forward with digital twins and so on? Yeah, they have looked at so many different things, but what is the way forward? So here are some things which maybe you should keep in mind. Embrace the concept now. So just embrace the concept for now. Read as much as you can. Read as widely as you can. If you are from built environment industry, do not just read of the application of digital twin in your industry. read across industries so you can have a holistic overall viewpoint of what is happening in the digital twin. Respect the journey. Learning will not happen by listening to one talk or attending one lecture or reading one book, or it's a journey, so step by step. Today it is digital twin we are talking about. Tomorrow we might talk about some other thing, because advancement of virtual reality, when that is combined using artificial intelligence in the domain of digital twin, we are talking about a totally different industry there. So keep on learning about that, keep on reading, yeah, step by step, one step at a time. Collaboration is extremely important. No matter which country you are coming from, no matter how learned you are in your domain, respect that there are other people also who might know things which maybe you do not know. So understand that collaboration, and I give thanks and appreciate uh, this thing which your president here, your association is doing. They are collaborating with people across different countries, bringing them together and trying to create some dialogue there. So collaboration is going to be very important there. Number three. Number four, regulations. They are very important. Ethical areas, laws, regulations. Maybe you can build a career just in that. So, for example, ethical implications of creating digital twins in Kenya, for example, or any place wherever you are interested in. Yeah, as a very interesting area to look at. Get out of silos, and I already spoke about that. Across different industries, across different areas, and be sustainable. And I want to reiterate this point. Go on United Nations Sustainable Development Goals. There are 17 different goals. Try to link it with their job. If you can do that, you will be very useful person for the society. Couple of things I want to say before uh, we close. So um, we had a short time here, just 1 hour more or less, and we are almost ending. We spoke about digital twins and so on, but this is just a start. If you are interested in this area, you will have to do a lot of reading. Um I don't know how much you already knew. I just gave you introductory level information there. But what I really want to say is that it's not necessarily the way I'm looking at it. It is not necessarily digital twins or different technologies or artificial intelligence and so on. The way I'm looking at it, that what you should really do is find something which you are really passionate about, whatever it is. Find some area. Maybe it is in construction industry, maybe it is in some other area, maybe you are still exploring that. What is it that really interesting for you? What do you really want out of your life? Try to identify that area, that passion. Sometimes it comes early in life, sometimes it takes a little bit time. Don't worry about it, keep on exploring, find that something, and then go all out in that. And the reason why I'm trying to say this, that it's very important to find something which you are really passionate about, is that the future is, AI driven, basically. So there are a lot of things which, a lot of jobs will go out, new jobs will come in. No matter which industry you go on, you will never graduate. After your bachelor's degree, you cannot really say that I have graduated. After your master's, you cannot say you have graduated. After your PhD, you cannot say that you know all. There is always new things to learn, especially the way new technologies are coming in. You will have to read a lot, you will have to invest a lot of time. And it can be very taxing and difficult if you are not really passionate and don't really care about that area. So you really need to find out that something which is your love, which is your interest, and then it will be easier for you in your career to progress, because it will not be work for you uh, to study more, or you will not get bored that, oh, I have to read more on this. As a matter of fact, you will be excited and so on. So if it is digital twin, if it is AI, if it is virtual reality, whatever it is, that does not matter. finding something which is very interesting for you, then going all out, and then continuously lifelong learning. I think that is what you should think of. Uh, that is it. Thank you very much.
Thanks a lot, Mr. Ahmed. So, for the really insightful presentation and for the amazing advice, indeed, you should find a job you love and you will never have to work a day in your life. Very famous quote. The next session of this talk, what we're going to do is for anyone who has a question, please raise your hand and I'm going to give you a chance to speak. If you can't speak at the moment, please type the question on the chat and I will read it out. So we will start with Williams. Please introduce yourself, then you can ask a question.
Hello guys, my name is Williams, at a university civil engineering student in second year. About the talk, I really love the talk by Mr. Tashfeen. It was nice and motivating. Yeah. So my question for today is, in our country, how can digital twins be adapted to suit the infrastructure limitations? Yeah, that's my question.
Yes, thank you very much, Williams. Yes, very important thing to reflect on and so on. I'm not very much exposed to Kenya. I just had one visit there. I stayed there for 2 weeks during the time of conference. That was the same time when there were some riots and some things were happening in Nairobi near the university. So I did not really get a chance to really understand the dynamics. But I did go out and hang out, made some friends. It was good experience. I think it's a beautiful country with a lot of talented people, with people who have a lot of dreams and hopes. But there are definitely some challenges in terms of governance and where the country is in that domain. Of course, there are some very big challenges in that. So the way I'm looking at it, maybe not digital twins right now for Kenya or for Jamaica or for Pakistan. I live in Jamaica, so I'm familiar with my country here. I have reasonable understanding of Pakistan also. So all these three countries, and I understand our participants are from these three countries. Maybe digital twin is not where we should be focusing on for now. It is good thing to read for now, but for now maybe the competency which we should in our countries should really build our capacities in is in data analysis, because that is going to make the way forward for us in artificial intelligence and in digital twins, and cybersecurity, which I mentioned. So for now, I don't see a lot of things happening in terms of digital twin, because infrastructure is the problem, because access to data is the problem in our beautiful countries. So because of these challenges, maybe not digital twins, but definitely data analysis, understanding data, having good with that. As a starting step, what can be done in, I don't know how many of you are working or whatever you guys are doing. Start building the data sets in your companies, in your universities, in the projects you are doing. Start building the data blocks on which in the future, if the opportunity will come, we will be able to create something in the domain of digital twin. So that is one way you should start. Outside of Kenya, I think you should look at other countries, how they have done. How they have taken the journey of digital twins, how they started and so on. What were the initial things they did? I gave you example of University of Cambridge, the project they have finished in 2022. Maybe going on their website, seeing those reports there, how they started. And maybe, doing those things, how they started. I think we can start from there, because we have to start somewhere. So It's okay. The idea is it does not matter where we are right now, Williams. That's not a problem. If Kenya, Jamaica, Pakistan are not up there when we are talking about countries which are good in digital twin, that is okay. But the point is that we should just start with maybe data and then see how it goes. I don't know if I answer your question or not, but these are my thoughts on that.
I think I can add something on that. I do have some experience in what engineers are using in terms of modeling. Right now, the country as a whole, from what I've observed, we are trying to shift from 2D structural modeling to 3-dimensional, and that, as Mr. Tashfeen said, that goes under simulation, not really digital twins, because digital twins is more of real-time data. And I think I noted that most of us, even before we joined this webinar, we thought that digital twins are the same as this simulation. So the moment you say that, it struck my head. So at the moment, we are still trying to shift from AutoCAD 2-dimensional drawings to 3-dimensional models in software such as Revit or Tekla structures. So we are still trying to shift to simulations. Then I guess after we are good with that, then we will shift to digital twins if the need arises. Yeah, thank you. Any other
questions?
Yes.
That answered my question.
Plus, maybe I can add here that, our president is speaking about CAD and those type of softwares. Become very proficient in those. Become really, really, really good in those. Know those type of softwares at the back of your hand. Even if you apply those type of things in your domain, you don't have to really go for digital twin. In my reading, yeah, that's good thing to know. But a lot of can be accomplished without using digital twin, just by using simulation, because it's not easy to be very good with CAD and those type of softwares. So start with that, and then in next 3-4 years, 5 years, can see how the progress happens. Thank you.
Thank you, and thank you, William, for your question. I saw Talal raised his hand. Did you have a question? If anyone has a question, please feel free to raise your hand. Any comment, you can still give a comment to contribute to the presentation. Yes, Simon.
Thank you very much for the opportunity. I want to say that the presentation has been wonderful, and Tashfeen has really given us a point of reflection to look at even in our studies as engineering students. My name is Simon Obote. I'm the organizing secretary of the association, and I'm a 4th-year student. So I had a question regarding the digital twins. In terms of their implementation, do we have some maybe ethical issues or regarding the same, or even, and by that I mean even some people may lose their job because of digital twins coming in, or are we, or does it mean that digital twins is coming to save and provide only great advantages? Yeah, thank you.
Thanks, Simon. I like your picture and the style. It's coming out nice on your profile. So this thing is very. A lot of people talk about this, that a lot of jobs will go away because of technology adoption, be it digital twin, be it artificial intelligence, and so on. That is correct, but that is incomplete statement. The statement is not complete. So this is true that a lot of people will lose their job and a lot of jobs will go out. But there are a lot of new jobs which will come in also. So we just need to identify and see what are the new jobs in our industry, whatever industry it is, and prepare for that type of industry, that type of job, develop those skill set, and then move from there. And I want to congratulate all the people who are here, because basically just by showing up here, you have shown some interest in your career, in your future planning, in all of that. In one way or another, you are interested. That is why you are here. Uh, if you are not interested, you might be doing something else in this evening time in Kenya. So that is a good first step. But don't rely on your university to prepare you for the future of work. Be it a university in Kenya, be it a university in Jamaica, be it a university in Pakistan, no matter where, be it a university in United States of America, no matter which university it is and how good it is and whatever it is, don't rely on them. They can just do what they are doing. They can give you the classes. If you are part of some associations, they can just do these things like doing some webinar, just like we are in a webinar and we are talking about that. It's just this, and it stops here. The true learning, the true going after something will start after we finish this webinar. As we close, that is where the start happens, that how you want to prepare for your future. When I'm not there, when your president is not there, you are alone there, and then you are thinking about that what skill set I need to prepare. Because many times what happens that even the course curriculum, even the way of lecturing, even the way of teaching, even the course content, many times in various industries, various universities in the world, it is not really 100% update. The class starts, professor runs the PowerPoint, which they have from over the years. And then the class stops, and then before you know, it is time for the midterms, and before you know, it's time for final exam and so on. So you know how it goes, and that is the same case basically in any university you will go in the world, even the best ones. Doesn't really matter the university. So that is why again I want to reiterate the point, finding something which you are really passionate about, and then your professor is there, your people are there just to run the thought with them. You have some idea, you go there, consult them, but then after that it is your own journey on that. So yes, a very important point which Simon has made, that a lot of jobs will go, and what are the ethical implications and so on. That is correct, but the truth, nothing to be disappointed in that regard. A lot of new jobs are definitely coming in. So you should just need to identify which area you are passionate about, then read the future direction of that industry, how they are going to prepare in the future there in terms of job requirements, whatever those are. Try to identify and prepare for that. Gain experience. Do a lot of voluntary work for different organizations, different companies. At this stage, if you are third year, fourth year, finalizing student, starting your masters, or even finishing your masters, and if you don't have a lot of work experience, don't look for money right now. Just look for experience. Anyone who can give you some chance to work with them, just go there, voluntary yourself for 1 month, 2 months, 3 months, gain some experience, go somewhere else, gain some experience, hands-on experience. If someone is working on digital twins in any aspect, in any area in your country, in your city, go there, introduce yourself, voluntary work with them for a couple of months, see what the challenges are there. And that is how I think you can grow very fast before you know. So yes, those are my thoughts.
I think I can add something to that, is
Sure.
that AI won't replace people. It is the people who leverage on AI that will replace those who stay on their little comfort zone, their little bubble, where those who do not want to embrace the future. And secondly, I like what you said about university not being enough. As a matter of fact, the main mandate of the Association of Civil Engineering Students, and I'm sure also for the Institute of Civil Engineers student chapter, is to bridge the gap between academia and industry. It's a huge gap, and there's a lot that we're not being taught here that is being practiced in the industry. So, and that's why we are here. So next, Yeah. Next, we have Fahad. Please unmute so that you can ask your question or make a comment. Make sure. Thank you, Fahad.
Hi, my name is Faja and I'm from YouTube. Sir, I had experienced something similar to that. Like, I want to comment on digital twin that you mentioned. Suppose I took coordinates, if I have coordinates of a plot, all right, and I import that data on Google Earth, I can mark the boundary. Then I can import how, all right. It's one aspect. And the second thing is that I had seen, I had observed that person has created a model and he has linked 3D model with seismic analysis and history time, seismic analysis, seismic response spectrum, and he from that he generated some results, and from that, if an occurs, what the damage that can occur, and what are the mitigation strategies we can adopt. This was one example that I had seen similar to in this context. And the example that I want to mention is about the US. I had seen hurricane maps and flood maps of USGS, United States system, USGS websites. I had seen different maps related to hurricane maps, and I've seen that they are progressing forward, and they have done a lot of work. They have visualized different. They have represents data in different forms, visual data through vector points. Like they have shown some dots on link that thing with time series. And what
Fahad, I'm not sure it's just on my side, but I'm
shown some which
we're not getting you. I think there's network issues.
Okay, so there are a couple of things here, Fahad. Basically, this is introductory level digital twins session, and the things you are talking about. First of all, did not get the hang of your questions or what you are talking about. But this sounds more like the making of plotting the data in the digital twin and so on. So basically, we did not explore that area in our short discussion. So in the future, maybe we can do something on those areas. But thank you for listening and so on.
All right, sir.
Okay, thank you. So is there any other question or comment before we close this session? Okay, yes, Muhammad. Please introduce yourself, then you can ask a question or comment. You are muted. Okay, we can hear you now.
Hi everyone, I am Mohammad Abbasisan from Nest University, Islamabad. I heard about a week ago about this term, but didn't realize how much it has wider technology issues with civil engineering. Thank you, sir, for arranging such a webinar. I think AI playing more role in today's technology, especially the civil engineering. You can't stay at a one point. You have to gain new things. So thank you, Mr. President and Tashfeen sir. A very good webinar to the point. As you said, it's introductory, but I am more curious about this as it will happen in coming days. Thank you.
Happy to host you, Avas. It is okay that you just heard about this concept of digital twin recently. That is perfectly fine. Nothing to really worry about that. As a matter of fact, it is good that while you are studying, you heard about that and then you attended this. So just run some searches on this digital twin in construction, built environment, read as much as you can. You will see a lot of application that, and maybe in your area, in your university, in your city, you can be someone who is pioneering on in this area. So again, as this was an introductory level talk, it was geared towards people like you, just to sensitizing them how wide the application is. So just keep on reading on this and you will be fine. Very interesting area to explore. Thank you, Wes.
Yeah, thanks a lot for your comment. So any other question or comment? Feel free to raise your hand. Yes, Brian. Please introduce yourself, then make the comment or question. Thank you.
Hello, my name is Brian. After hearing about digital twins, it reminded me about BIM, Building Information Modeling, whereas BIM is part of the construction and designing phases. I've heard about digital twins as if it can be used in the operation of phases of projects. Are they the same thing, and can we categorize BIM as part of digital twin? Yeah, thank you.
Yes, thanks for your comment, Brian. I appreciate it. Yes.
Oh, he was actually asking whether BIM and digital twins are the same things, or if they can be categorized differently.
No, no. Yes, there are differences in that. Digital twin is only digital twin when it is two-way information and you can put in information in that, and then it is giving you simultaneously, it is giving you some results on that, and then you make some changes in the component, and then it shows you that what will be the impact of that. Those things are sometimes missed in the software which you mentioned, but most of the things can be done by BIM. So digital twin is not necessarily, it is something good to know in the countries we are targeting here, Jamaica, Kenya, Pakistan. It is good to know about these things, but the idea is that by using other methods, whichever you are using in your discipline, you can do a lot. It is just good to know about how digital twin works, but in short, no, they are not.
I can also add on that, and I remember Mr. Tashfeen said that before we come to now digital twins, we have to first model. So modeling or building information modeling comes before digital twins, where we first create the layout and the exact model of how the buildings or infrastructure, that is the civil works, is. Then it comes now on the next level where we have the digital twin, is where we have the real-time data of whatever is happening on the building. Well, I think it can also be applicable on the strength of a structure. I remember watching a presentation of a civil engineer who went into IoT, where he had sensors on a bridge that could tell the strength as the bridge aged throughout time, through the time dimension. So as the bridge is being used, he could get the real data. Now that was his study. So most likely anytime soon it will be implemented. So at that level, so when we model that bridge, that is where we have BIM. But then when we put in those sensors, as this presenter that I watched, that is when we go to the level of digital twins. I hope I understood you correctly.
Oh yes, no, Def, you explained it very well. Congratulations.
Thank you. So any other question or comment? Brian, I hope your question was answered.
Yeah, thank you.
Oh, you're welcome. So any other question, guys? Okay, so thank you all for joining us today. And thank you, Mr. Tashfeen Ahmad. Uh, we are namesakes. So thank you, Mr. Ahmad, for joining us today and giving us these really important insights. I really learned a lot. And I'm hoping to see you once again for another session anytime soon. Yeah, so thank you, everyone. And we are all to leave. We are all free to leave the meeting at our own convenience.
One last thing I wanted to mention, if I can take a second, is that you are here in the webinar. Now we are leaving. So actually, the true webinar starts now as you close off this. What will you do with your time now as you are closing off? Maybe you will make some notes that what are some areas you want to study in the future, and then maybe do some studies going forward. So what I'm trying to say that as we close this meeting, the real meeting with yourself and your future will start. So please pay attention to that. Thank you very much.
Sure, absolutely. Thank you.